Welcome to Christ OpenCourseWare. We are continuing with the data structure in linked list. In the last video, we have seen operations in linked list and I have completed the traversing operation of linked list. In this session, we will be dealing with insertion of linked list. In the insertion algorithm of the linked list, insertion can be divided into three categories. We can insert at the front, we can insert at the end, we can insert at any other positions between the front and end of a linked list. Before going for the insertion algorithm, we need to know another procedure or algorithm known as getNode. What is getNode and why do we use getNode? We have seen that in the last video I have told you linked list is a dynamic data structure. So if we want to insert, we don't have space in memory or we don't have a reserved space in memory. So what we have to do is first we have to get a node of the needed size and then we have to insert it in the linked list. So in the getNode algorithm, what we are going to do is we'll be searching in the memory bank or available memory pool of storage for the perfect size of node which we need, and then we take it and we insert that new node into the linked list. So taking for the procedure getNode. The algorithm is written here. Before that, I will explain it as an example. In the before sessions, we have seen the diagram of available store. We have an avail pointer pointing to the memory pool of storage, and what we have to do is here nodes are available of different size and we have a particular size or we need a particular size of node. So we go and search for the particular size of node that we need, and if we get that particular node is returned to the algorithm. If we are not getting the particular size, then we will get null as the return. So let's go for the algorithm. As I said, if avail equal to null, if avail equal to null means, that means we have no memory, that is avail will be pointing to the null, that is the last one probably, and we have insufficient memory. The else part, if avail is not equal to null, that is we are having memory, then in this part we will be using, we will be searching for the particular size of the node. Now let's take another variable ptr and assign it as avail. So now ptr will be taking the duty of avail. Now next we have the while condition. In this we compare the size. If size of ptr is not equal to the size of node and ptr of the link is not null, we go on searching. So what does this loop mean? Unless you have the ptr as size of the node and ptr of link is not null. When do you have ptr of link as null? When we reach the last node in the memory. So the ptr of link not equal to null means, equal to null means you have reached the end of the memory, and ptr not equal to size of node means you have not got the size. If so, here we have two conditions. There is an AND. So what does AND represent? If this condition is true and this condition is true, then while loop works. So what happens here is, if size of ptr is not equal to size of node, that is ptr is the particular node we are now handling, and we need a node of size node. Node of size node. Node of size node means, suppose let's consider an example. We are taking the data part as integer. So you have 2 bytes and you will have to point to another node which is also containing a integer node, integer data. So it's according to this size. Okay, then size of node is the particular size we need and ptr is searching for the particular size. So in the while condition, if the size is not equal to node and ptr of link is not equal to null, you have to go forward in the memory pool. And here one thing is also happening. What is? It is ptr1 equal to ptr is equal to ptr of link. Why does these two statements imply? Let's suppose from the beginning I have started from avail, I go to the first node, then what happens? Suppose the condition is true, that is this node is not of size node, and this is also not the link part is also not null, so I can go for the next node. Now what happens is ptr1 is equal to ptr, that means in the first running of loop this node is known as ptr1 and then ptr equal to PTR of link. That is, this statement is like an incrementing statement used in linked list. So PTR of link is this part, and that value is given to PTR. That means now PTR will be pointing to the second node. Okay, then it checks for the second condition. Is the size of this PTR equal to size of node, and is the link part of this node is null? So we suppose that link part is not null, that part is true, and we suppose the PTR of size of this PTR is not equal to the size of node. Suppose, then it goes for the next chance. Then what happens here? The second running, this node becomes PTR1 and this node becomes PTR. Okay, I'll explain it once more. The first running of the loop, we have, suppose the node is not of size PTR and the link part is not null. We can see it from the diagram. Then what happens? Both conditions are true. We go for the statements in the while loop. Then what happens? PTR1 equal to PTR, that is PTR. This node was previously called as PTR and that is assigned to another variable known as PTR1, and the link part of PTR of link is given the new value PTR. PTR of link means what happens? It is referring to the next node. So the second node is known as now PTR. Now the second running of the loop, suppose again we suppose this node is also not of size node, then the condition is true. Then the PTR of link is not also null. You can see it from the diagram. And then what happens? This node is again given the value of PTR1 and the PTR link part is not null. So we give it for the third node, and that node is known as PTR. Okay, this goes on, this loop goes on until we find a node of size PTR or until we find a node which has the link part as null. So now suppose in this diagram, this is the node I have got. This is the node I have got. That means in our figure, the third node, this size of node is equal to the size of PTR. So at that time, while loop is exited. Now it comes, and then the next loop we are going to face is if condition. Now what is the if condition? Since the while loop has exited on the basis of this condition, in my example, I have exited while loop based on this condition, that is size of PTR is not equal to size of node. It should be true, but now I have given as it is false. So it is exited, and now next I have to face the if condition. What is if condition? If size of PTR is equal to size of node. So this means that this statement means that I have got a node of needed size. And now what happens? PTR1 of link is given PTR of link, and we have to return PTR. What does this statement mean? If this is a node I have got according to my size, then this node is known as PTR and the above node is known as PTR1, right? So in this link part, what happens is, suppose you have another node here, then naturally this node has the address of the next node, right? So what we have to do, before this node is taken away, you have to give the address to the previous node. That is, the address which this node holds is the address of the next node to it. So that should be given to the previous node, and that is what is being done here in this statement. PTR1 of link is given the value of PTR link. That is, PTR link holds the address of the next node, and that should be given to the before node, that is known as PTR1 of link. And then you can take PTR away from the available pool of memory, and that is done with the statement return PTR. Suppose we don't get this condition as true, that is the first condition in while loop as true, then we exit on the basis of this one, that is we have reached the null part, PTR of link not equal to null, and that is referring to the else part. That means we have no memory available according to our size, and then we have to return none, and then the corresponding if statements are closed, and last we come at the end of the algorithm. So this giving us brief summary of get node. This get node procedure is called in the various insertion algorithms we are coming to see, and you have to keep it in mind that we are searching in the memory for the given size of the node which we want, and if it is available we get it as a new node. That will be referred to as new node. Okay, next we will be seeing the insertion in the friend. Next we will be going to the insertion algorithms. In this we have two algorithms. First we will be dealing with the insertion in the front, and next we will be dealing with insertion at the end. Going to the insertion at the front. Inserting at the front, we have two cases. Suppose we are inserting as a new linked list, or we will be inserting in the front of an already existing linked list. So what happens? We can take a diagrammatic view first. Suppose we have a linked list, already existing linked list, and we have 1, 2, 3, a 3-node linked list. So what does happen if you want to insert at the front of this linked list, and suppose we have a data 0 to be inserted in the front. Okay, so as I told before, first before inserting you have to get a node from the memory pool, and this node, say let it be this, will be termed as new node. Then in the data part we have to keep 0, that will be done later. Before that, in an already existing linked list, what does happen here? You have to have the header node of the link has address of the previously first node. Now this should be given to the new node's link part, right? So what happens is, now new node link part should be pointing to the first node. That is, the value in the header link part is given to the new link part, right? And when you give the data for the new, you have the new node at the front, right? Now let's look at the algorithm. As I said before, you get a new node with using the get node procedure. You get a new node and it is termed as the new. Then if new is equal to null, what does that mean? We don't have memory, right? So we'll go for the else part. The first statement is, as I said before, in the link part of the new node, you give the header link part, the value in the header link part. What is the value in the header link part? The address of the first node, right? The address of the first node will be now given to the link part of the new node. And then the new data part contains the x. Suppose let x equal to 0. So that is the data, and I give it to the data part of the new node. And now header link will have the address of the new. That is, this connection is established. This connection is established means now header link part of the header node should have the address of the new node, since it is the first node in the updated manner. So header part of the link node, the link part of the header node will have the address of the new node. Link part of the new node has the address of the previously first node, and which it gets from the header's link part, and the data part contains 0, and the connection is established. This is the case when you have when you insert in a new this is the case in which you insert a new node at the front in an already existing link node, right? Now what happens if you are going to insert a new, or you are going to create a new link list? So if you're creating a new linked list, naturally you will be having the header part. As I've said before, header part contains no data part, and the link part will be either null or it may contain the value of the first node. Value means the address of the first node. So in this case, I have not created a linked list yet. So I have a header here, and the link part has null value. So what happens here also, this portion is referring here. So then here, as I said before, you get a new node. This node is known as new. The link part contains header link. Header link means the value in the header's link part, that is null. So naturally, new node has the link part has value null. You get the data x. Our x value is 0. Now header link contains new. That means what happens? Now the header of the link portion can point to the new node, right? So the connection is established here, and you get the first new node at the header point, that which points to which is pointed by the header node. Now what happens when you insert at the end? Suppose we can take the same algorithm, same example. Now inserting at the end. What do you mean by inserting at the end? You have already an existing linked list. You have already created, say for example, 3 nodes, or adding this node you have 4 nodes. And what happens? You're going to insert a new node at the end of the linked list. So what happens? You have to have a new node at the end of the linked list. Suppose this is our new node. This is our new node. Now what I have to do if I want to insert at the end? Naturally you have to traverse all the previously created linked list. That means you have to start from the header. You have to go through one by one node until you reach the end of the linked list. We don't know when the end of the linked list until you have a link part as the value null. When you have a node with the link part value null, you mean that you have reached the last node. So we have to reach the last node by traversing through the linked list, and for traversing through the linked list until the end, you will have to have a condition, that is the link part is equal to null. Link part equal to null means what happens? You have reached the last portion. Now what happens? So first you traverse, you have reached here. Then what happens? Then nothing much more. You have to just create a connection here. For this connection to be created, what should be given? Suppose you have reached the last, and this is known as PTR. This node is known as PTR. Then PTR of link contains a value new, right? And the link part of the last node should be kept as null. You have to insert the data. Let it be, say, 4. Since this is a new node and we have the data as 4, that will be inserted. Okay, now we'll go through the algorithm. First you have to get a new node, and using the procedure get node, you get the new node. Now if new is equal to null, naturally you have the condition that is memory is insufficient. Now for us, we are considering the else part. What is else part? I have told you before, we have to traverse, starting from the header, you have to traverse the full linked list to reach the last node. Now PTR is starting from the header. Now PTR is given the value of header. Now what happens? While PTR of link not equal to null, in the previous algorithm I told you, PTR of link not equal to null. This while condition works until the condition is true. So what is the condition should be? PTR of link not equal to null means if the link part of the current node which is traversing is not null, it goes forward. So until the PTR of link part is not null, you go forward using the statement PTR equal to PTR of link end while. When does this condition, or when does it comes out of the loop? Until you encounter a PTR which has a link part equal to null, and that will be most probably the last node. Now what happens? At that time, when this while condition exit, what happens? It will be reaching the last node, and that node will be known as PTR. Now what is the next statement? PTR of link is given new, means since this is the last node, the link part will be given the value of new. That is, new node's address is given to the last node. Data part of the new is given x. In this example, x is equal to 4. And we have the connection established. The last new node has been inserted at the last, and the algorithm gets stopped here, right? And so a little revision. You have to get a new node using the get node algorithm. And if you get it, if if new is not equal to null, you go for the insertion part. In the insertion, what is happening here? Starting from the header, you traverse through all the nodes in the linked list until you reach the last. And when you reach the last, what happens? Let that node be PTR, and the link part is inserted with the value of new. The connection is established here. The data part of new is given the value, needed value, and you put the null part, link part as value null. then the insertion at the end is completed here. Next, we will be seeing the algorithm in inserting at any point. Okay. Now, we have already seen inserting at the front, at the end, and now we will be seeing insertion at any point of a already existing linked list. Suppose this is our linked list here, and we are going to, that is, we already have 1, 2, 3, 4 nodes, and I'm going to insert a linked list at any position. So the position is determined by a factor, or moreover factor, it is a value. You have a key value, and the new node that is going to be inserted will be after the key node. The key is the data. Suppose you have an already existing linked list with a value 1, 2, 3, 5. I'm going to insert a new node which is going to have a data known as 4 after the key 2. So the position will be between 2 and 3. The new node will have the position, right? So as I said before, we have to start with the get node procedure. You have to get a new node, and that is known as new. If new is null, that means the memory is insufficient. If it is not, we have already received a new node with the name new, then we have to start from the header. Okay, now I said we have 2 factors here to be considered, and you have to reach the position, that is the data. If the data of the PTR node is key, then we are going to insert it after the key value. So what should be the condition for the while condition? In while condition, the condition should be true for us to go forward. So the condition will be like, if the PTR data is not equal to key and PTR of link is not equal to null, you go forward, right? PTR equal to PTR of link. That is, if the key value data part does not have the key value and the link part does not have null value, you go forward, and this while loop gets exited when either of the condition becomes false. Suppose this condition gets false, that is PTR of link has got a null value. That means it has reached the end of the linked list. That means you don't have the key value, right? If you're in the linked list which you are given, suppose I gave it as say 6, then is 6 present here? No. So naturally we will reach the end of the linked list. So what happens? You will get a message saying that the key value is not available. Then this is the case. This if condition refers to the exiting of while loop according to this condition. This condition means if the linked list has reached the end, that is the link part has null value. Suppose it exists on the basis of this value, that is PTR of data is not equal to key, means it has the value key. That is PTR of data equal to key means, suppose I have given the key value as 2, then the key value is present in the linked list. So that means I have to stop here, right? Now when stopping here, that means I am having this node as a value PTR, right? So I'm going to insert the new node after the key value. Now what will happen then? In the link part of the new node, I put the value which is already existing in the link part of the PTR node. That is, PTR node will be containing the address of the next node. Now as the new node is coming between the two, so naturally the new node will have the address of the next node. So this is done first, right? Then the new data part is given the value x. Suppose x here we have a value 4. I put the data in the data part. Now this PTR node should point to the new node. That means PTR link part should have the value new. Then the insertion process is complete, right? So I'll say this one more. What happens is you have to insert the new node between the nodes 2 and 3. That is after the key value. I have given the key value as 2. So what happens here? This PTR node has the address of the node which has the data 3. Now this address should be contained by the new node. So what happens? The link part of the new node will have the value of PTR link. PTR link means the link node which has the key data 2 has the address of the node which has the data 3. So this now should be held by the new node. Then the new link part is given to the new node. So this statement, new link part of the new node contains the address of PTR link part. Now the data is given to the new node. Now Peter link should point to the new node, so it has the value new. This is the end of the insertion, which we have already seen in 3 categories. First we have seen at the insertion at the front, next we have insertion at the end, and now we have done insertion at the in between positions. The between positions is determined by the key value. So as I said before insertion, you have to definitely write the procedure of the get node first, and then you call the get node procedure each and every time when it is needed. Thank you, students. Next we will be seeing the deletion algorithms in the later videos.